Later after class, I will ask about the university stuff. Okay.
Yeah. Okay. Okay. You
Okay.
still didn't forget. Okay. So, okay.
Okay.
So, did you see, first of all, did you see this figure before? Can you see my screen?
Yes.
Okay. Did you see the figure before?
Yeah.
Okay. So, what do you understand from that?
It's like sorting in array. Sorting array.
Uh, not really, but it's okay. So it's just explaining the difference between an index of an array and the element
Oh,
in the
okay.
array. So I just want to make sure that the difference between the index and the element inside and the place of the index is clear for you. This is just to clarify the concept only. So is it clear
Okay.
for you that this is,
Yes.
we always start from 0 and we end up in a number which is less than the array length? So I assume that the array length is 8 here in this current situation, and we are starting from 0 until 7. So is that clear to you?
Yes.
Okay. And you know that if we want to get from an array a position, an element in the index 2, so that is how we should come here, right?
Okay.
Is that clear to you?
Yes.
Okay, so let me also, okay, so that's clear. Let me come here. Yeah. Yeah, I want to explain to you the concept here of, do you know, did you hear before about procedural programming and object-oriented programming? Did you hear about this before?
Just the object oriented.
Okay, so did you create any procedures before? So did you create any function or procedure before?
Function. Just define the function or what?
Yes, yes. Did you create any function? And do you know why we need to create functions in our programs?
To make the program work executable or what?
No, not really. Okay. Typically, when we write programs, it's not as simple as most of the time we are taking as an examples here. So most of the programs you should write in real life might be thousands of lines. This is on average. So you do not want your whole code to be just in one function. You want to divide your code into separate, small, maintainable functions or portions. Okay, so how that helps actually. So
Because it
when
modular.
yeah, okay, is object oriented is more to the modular concept, but okay, we can accept for the moment that when you divide it into function, you make it somehow kind of modular. Okay, so also it helps on the software reuse concept. So when they come up with the object-oriented programming, they make it for many reasons. One of them is to reuse the software. So if you have a project, you finish it and it's done, you already write a lot of software in that project, maybe thousands of lines, 6,000, 7,000 lines, and then you want to reuse that software again in your future projects. How can you do that? So unless you cut your software into separate parts that you can reuse, you're not able to do that. So functions help you to cut your software into parts that every part of those do a specific purpose or serve a specific purpose. Okay, and that also will lead you to be able to test your software in a proper manner, because testing software have its own its how to say, and this is I would say, a different branch that maybe we will go through, but I'm not sure if we need to go into details or not. But testing a software is actually steps that you need to write a certain codes to be able to test if the function actually do what is supposed to do or not. Okay, so you are not able to test a function that is too complicated. You have to simplify every function in a way so you are able to test it. Test it with the commands or with a code. So testing, okay, we can test a function. Oh, we are able to add two numbers using a function. Okay, that's clear. So we test it visually or test it even without writing any extra code. But testing using something like unit test or even integration test, all this need us to write a code to do the testing for us, to assure the code will tell us, okay, you pass a test or you fail. So it could be that you write a function, it do its job, it's able to run, but it will fail the coding test. Okay, so that's a different story. So this is a different from our normal visual test that we do. Okay.
Okay.
Okay, good. So you know now that we have to divide our code into smaller maintainable functions. We should always give our functions a proper name. A proper name means from the name, we should be able to know what the function is doing. If you are not able, if you are making a function that you don't know really what to give it a name, it means that you are making it too big or too large. That's why you don't know what it's actually doing, because it's doing a lot of things. Okay, so if we want to make a function for adding, so we should make maybe add numbers or subtract numbers or divide numbers. So it should be as simple as that. Of course, we need to try that in practice to be able to see how it works. Okay.
Okay.
But so far clear.
Yes, clear.
Okay, good. So
this is for the problem solving step, right?
yes, yes,
Or
yes.
is it related with the procedural or not?
Kind of, yes. But let me, yeah. So it's good that you highlight, you remind me. So I just, before I leave the functions and procedures, I would like to ask you also one question before we leave that point. Do you know what's the difference between a method or a procedure and a function?
I'm sorry, I can't hear.
Okay. Do you know what is the difference between a procedure and a function?
Uh, Function is the step. Procedure is like the workflow. Something like that.
No, no.
Oh, no.
There is clear difference between both of them, which is the function should always have a return value. So let me see here. Let me see. Okay. Let me see. I want to share with you the screen here. So okay. So just to share with
Okay.
you. So now if I look to this add numbers function, so this is a true function that returns to me a value. So I pass it some parameters and it returns back for me something. But then I can modify that function actually to act as a procedure or yeah. So in a way that I would just do this kind of sorry. Okay. So if I modify it in this way, so it become a procedure. It's not a function anymore. Why? Because it does not return to me a value. So that's the difference, the main difference between a function and a procedure. Is this clear to you?
Yes.
Okay. So I can see now we are more focused on the software programming concepts in general. We are not focusing only on the data science. So if you are focusing only on data science, it means that certain software concepts will be missing out, because the way we write the code for data science somehow um, most of the time we don't really write object-oriented code, and most of the time we don't really care too much about creating functions. Most of the code I have ever seen, that it is only just one or two functions that's used, and the remaining of the lines it just uh, laid out in the main program. So, but of course, when you do this way, you never learn how the real software works. If you want to write software that works for programs like C# or even Java, or even um, uh, any full stack software that write anything for the web, so that's totally different actually from the data science part. Okay, so even if you want to integrate the data science part in a normal um, full stack software that appears on the web or even to the user, so you have to understand the normal software concepts, how you create a class, how you create an object, and then how you interact out of that. Not only use the built-in object that's created by Python or is offered to you in modules. So this is in short why we need to go through that. Okay.
Okay.
Okay. Good. Let me go back here to the. Okay. I will try to go through this part. So to improve your problem solving skills, actually, uh, it's clear. We already know that you need to practice regularly. So if you're taking a math class and you don't solve exercises regularly, then you will forget and you will lose your skills that you even gain. So neuroscience um, um, how to say theorists say that you should always have a fixed pace practice. It means that you practice, I wouldn't say every day, but every 2 or 3 days. If you want to remember something and you put it in your long-term memory, you should always do a practice for it every 2 or 3 days. That will make the information that you are trying to master um, permanent in your or not permanent, stored in links inside your permanent memory. Okay, so you will not forget it very easy. Okay, and if you can recall back, I don't think that I explained that concept to you before. So if you are riding a car or trying to drive a car for the first time, you'll find that you're not able to speak or to do any activity uh, during your trial to drive a car. But by time, you will be able to look at the GPS, and you will be able to even talk to the people beside you when you are driving. But for the first time, you will not be able to do that. You will full focus, and you are fully focusing just only on driving the car and making it move and stop. Am I right?
Yeah.
Did you try? Are you driving car?
Actually,
No.
I didn't have a license.
Okay, but what about the bicycles? Or what about motorbike?
Yeah. Bicycle.
Bicycle, okay. So with the bicycle, when you try to ride a bicycle for the first time, this is the same. You're trying to balance yourself you're trying to not to fall, and then you are fully focused on what you are doing. So when you are fully focused, it means that you don't have any links that help you to do this writing in your permanent memory. You just using the part. We have two parts of the memory: permanent memory and working memory. So the working memory have only limited capacities. So this limit capacity, they say average student have, or average person have 4 places to hold 4 different information. Some people have 3, some people have 5 or even 6. Okay, so that differentiate people who are fast learners from slow learners. So that is part of the working memory. So it doesn't mean that the people who have limited capacity in the working memory, they cannot achieve or they cannot reach the goal. No, they can, because even the teachers in the American universities who explain this concept about neuroscience and working memory, they, they themselves are hikers. It means that they are slow learners. Okay, they are doctors, they are PhD holders, and they are slow learners. So there is no problem with that, except that you have to follow different concepts from fast learners. So it means that you need some persistence. You need to, of course, have a strong will, and you need to put more efforts. But definitely you are able to reach the goal. Okay. So now back to the working memory and the permanent memory. So if you are riding a bicycle and you are not able to do any other activity other than just riding the bicycle, it means that you don't have skills in your permanent memory yet. You didn't build the skills in your permanent memory. When you practice always riding the bicycle every day, you will start after maybe 2 or 3 weeks to have the ability to ride a bicycle and even do something beside that. Maybe you're able to look at your sides for a green scenery, or even sawabadi, for example. Okay, so you're able to do some activities. You're able to even talk to people. But if you are still learning, you are just only hardly enough to ride the bicycle and control it and even maintain its balance. Okay, so when you are practicing more and more, it means that you are building links inside your permanent memory. And when you are building these links by time, um, your working memory will be only calling that links to do things automatically for you. So at the moment you are bracing when you are listening to me, and I'm also bracing, and I might be doing other things when I'm explaining. So it means that I only can, if I want to breathe, so I call certain links automatically. My working memory automatically calls certain links in my permanent memory to do this breathing for me. I don't need to focus on breathing when I'm teaching now, or in the normal conditions. So certain things your working memory will help you to do automatically if you practice it. So the same we want the same to happen in your study. We want you to be able to solve problems automatically. We want you to write functions and find solutions for small problems automatically. So how you can do that? By practice. When you do a lot of practice, you are building links in your permanent memory that your working memory can recall automatically for you. So you don't have to put too much focus, too much effort to be able to solve a problem. Does this make any sense so far?
Yes, yes.
Okay. Uh, so did you hear these things before?
Problem solve, yeah, but not in detail.
Okay. I mean, no, I'm talking about this permanent memory and working memory. Did you hear them before?
Oh, just the simple theory about that.
Okay. So again, if we're having a large problem, the key solution here is that we divide that problem into smaller problems. Of course, this is easier said than done, but I find it a way. So I will teach you a way. When you see certain problems, then I will tell you, okay, without going into, if you read the details of the problem, maybe things will get complicated in your mind. Then you start to be overwhelmed and you don't know from where to start. But I will teach you a way that you take things step by step in a way that we can always, every certain moment that we can always write a few lines of code. And then we work on improving that lines of code little by little until we really reach the goal of finishing or solving the whole problem. Okay, so people who start programming, they typically, I mean, and if you're taking a normal degree for software programming or computer science, then they will teach you something called pseudocode. Typically, people who are studying data science only, maybe they will never hear about pseudocode. So pseudocode is just a simple programming language um, that just use simple English words, okay, and everything in it works. So even if you write a definition with a small mistakes, it will still work, okay? Because why? Because they don't have a compiler for that. They just write this, the pseudocode. They come up with a way to, for you to think about solving a problem in a simple English syntax. Okay, so of course it have its own syntax. I am not sure if we have the chance or time even to go through pseudocode, but I will maybe, if you prefer, maybe I can prepare for you one or two examples in the next class just to see how the pseudocode looks like. So typically, programmers, they should not rush to writing a program on the first I mean, once you see a problem, oh, you want to solve the problem in this way, and they start writing code immediately. No, they need to first come up with a design. So if we are talking about adding two numbers or subtracting two numbers, that's too simple. We don't need to spend too much time planning for that. It's just only one or two lines that we need to write. But if we're talking about solving a complicated problem, we need to have a strategy. We need to plan first what we need to do, because you will find yourself having there is many options for you, or there is many roads for you that you can go through to be able to reach a solution for your problem. If you choose the wrong road, you might end up adding or writing extra lines of code to be able to reach a solution. So planning help you. So you plan first, and then a later stage you can come up with something like pseudocode, and then later on you improve on the pseudocode, and then you start writing your code in Python. That's how it should work, especially with a complex software. But with a simple software, typically we try to not we try, but it is not worth it to spend so much time planning and writing pseudocode. But for complex one, yes, we should try to. I mean, this is the standard way of writing software. Did you hear that before? Did you hear about pseudocode before?
Yes.
Did you hear about it? Okay. Did you write pseudocode before or see how it works?
A little bit, but I'm not in detail about that.
Okay. So, okay, that's clear. I will taking that into account. So let me go through the next thing here, which is to test your code as you go. So that I explained to you a while ago. There could be official way of testing code, which means that it needs for you to write a code to be able to test your code. So that is, for example, let's call it at the moment unit test. It have other test names, but let's call it at the moment unit test. So unit test, you're writing a code that you expect to pass a function, one or two or three parameters, and you expect the output from that function to meet certain specification, okay? Without going into much detail, so if I'm adding two numbers, I'm expecting this addition to happen So it means that I will write a code to test if my function returns to me the sum of the two numbers or the three numbers that I added. So this is in short testing. But in our case, before we learn testing, can you still hear me?
Yes.
Okay. So in short, if we want to test a code, I always say that, do you know this command print? Just now
Yeah.
you write it right. So print is your always all the time friend. So whenever we are writing a code, we should always try to use print to be able to see if our function or our code is working or not. So everything you're able to print, everything. You are able to print arrays, lists. You're able to print statements that can tell you if you are working, your code is working correctly or not, or following a certain path or not. You're able to print variables, and that's important to us. So always put print statements to tell you how the code, how your code internally is working. So most of the time, I'm able to um, to know if my code is really working, or even troubleshoot it or find a solution for my code using print statements. And not exactly print all the time. Certain times I'm not able to print if I'm building web applications. So I use something called a log. So log will write a statement, or even whatever I write in between here, in a text file, and then later I open the text file and see. Because on web application, it's very hard for you to always write to the screen. It's different from Python that we are testing at the moment. So with Python, oh, okay, you can just use a print statement and it will print something to your screen. So let me just, we talked a lot, so let me just share with you some code here, just to give you an example. So let me think here how I can okay. So I try to modify this function in a way that can do some print statements here for you. So I would say, if we want to modify the function slightly in a way that I add 1 to my input parameters. So we know that this is my input parameters, right? X and Y. Hello?
Yes, yes.
Okay. So if you lose focus, let me know.
No, I'm just listening.
Okay. So I am adding 1 also to the Y. So it means that any numbers I pass here as a parameters, I will modify them in a way to add 1 to them. Okay. And then I will print the return, or even just return. Okay. So if you remember from last time, we used that command. We call the function add numbers, and then we assign the returning or the return values to z variable, and we print the z variable. So let's try to run here and see. We push that up a bit. Okay, so as you see here, okay, it add numbers, but so, oh, I forgot to tell you. So at the moment we have to close, and you have to use the same link again to enter to the same session, because we will be recording each 30 minutes by 30 minutes. Okay.
Oh, okay.
So we close now and we open with the same link again. Okay.
Okay.
Okay.